All right, good morning, everyone. Thanks for joining us. We want to welcome everybody that's joining us out there, and we're excited to cover this topic with our partners, the Rehmann Technology Group, ensuring your e-commerce network is secure. Pretty important topic, not only from the security standpoint and everything that's going on, but e-commerce has continually grown tremendously this year, especially through the pandemic, with everybody going into buying more things online, obviously. So we want to welcome everybody. We want to introduce Jim Carpp, who's the Chief Digital Officer for Rehmann Technology Group, who's going to be our moderator. And we'll do some introductions. So Jim, you want to, there you go, our panelists. Exciting to have these three panelists, incredible years of knowledge in each one of their spaces. So first I want to introduce Kevin Yenglin. Kevin is the Information Security Manager for Rehmann Technology Solutions. His current role, he's leading Rehmann's internal information security team, overseeing IT security strategy, cybersecurity tools, vendor risk, vulnerability management, and change management as well. So Kevin's been working in the IT industry for over 10 years with roles in consulting services, application security, and data center operations. So welcome, Kevin.
Thank you, Eric. Happy to be here.
Yeah. Next, we got Mike Eldred. Mike is one of CQL's co-owners, and he's one of our leading senior software architects. He has 25 years with CQL. CQL's been around 26 years, so he's right there, right from the start. Started as an intern, and Mike has tremendous knowledge in the software development space in many different languages and all kinds of different projects and leading our e-commerce team these days. So welcome, Mike.
Thanks, Eric. Glad to be here.
Absolutely. And then last, we have Dr. Jared DeMott. And Jared is an engineer, entrepreneur, and leader in the space of cybersecurity. He's previously served as a vulnerability analyst with the NSA. He holds a PhD from Michigan State University. He regularly speaks at Cyber Matters at security conferences, and has been an invited lecturer at prestigious institutions such as the U.S. Military Academy. Jared is a Pluralsight author and is often interviewed by media, which I've seen him on many times, to weigh in on cybersecurity matters. So welcome, Dr. Jared DeMott.
Yeah, thanks.
Great. So I'll kick it over to Jim, and we'll get going.
All right. Welcome, everybody. I'm Jim Carpp, and I want to thank Jolene and Eric. They've done a lot of energy, put a lot of energy into putting this together. And really, what we're going to cover today is several different areas from an e-commerce perspective. If you're out there today and you're saying, how do I get started? Or maybe you already have something up and running, we've got answers for you today. We're going to look at it from a security perspective. We're going to look at it also from a development perspective. You've got a very seasoned panel here. So why don't we go ahead and get started? The first thing is if you have questions, please feel free to send them in. Jolene's going to be watching for the questions. And if we need to, you can stop us at any point in time during the presentation, and we'll make sure that we can answer those. If not, we'll definitely answer the questions at the tail end. So gentlemen, in kicking it off, we hear a lot about software security and all those different aspects. You hear stuff about like SSL certificates. What's it all mean and how does it all fit together?
I can take a stab at that, Jim. Thank you. I say if you're going to conduct any type of business online or e-commerce site, you're going to need to have what they call an SSL certificate tied to that site. That certificate is going to help with encryption, communications between the customer's browser and your website. And this also gives you the little S that people are familiar with when you see the HTTP in front of a URL, you get that added S for the secure layer. It grants you the little green lock icon too that a lot of people are probably familiar with. And without it, you just have HTTP. And those communications are essentially going in plain text. And one more thing to add is that Google actually ranks websites based on whether or not they're using SSL certificates. So if you're not using an SSL certificate, and you're going to get ranked lower on Google's results, and your marketing team's not going to be too happy. How do you get an SSL certificate implemented into your website and make use of that secure connection? You're gonna go to your hosting provider basically. They'll be able to help you out with it if you're just starting out. And there has been a slight shift when it comes to SSL certificates. So On September 1st, I think it was, you can no longer get certificates that are good for 3 years. Now they're only offering a 1-year certificate. And this is because the longer the certificate is out there, the more opportunity attackers have. They could try to decrypt that certificate and then, intercept those communications. So rotating the certificate makes it harder for attackers to try to brute force and get into your site and see that information going back and forth.
So Mike, security is a feature. Can you kind of, parlay that onto the SSL certificate, and what's that next layer that you can leverage?
See, just a little plus on to what Kevin was saying there is,
Okay.
Even if you didn't have a e-commerce site that you were collecting information on, so people's email addresses, typically doesn't seem secure, but as time goes on, it's becoming more secure. Google and as well as Firefox browsers typically want you to have that SSL on your site so it doesn't flag inputs on the browser as a suspect. So that's definitely something to keep an eye on there. And another benefit to that as well, HTTPS brings along with it some performance benefits when it comes to pipelining of data, especially when I guess in the context of when you bring CDN caching in the mix there. So that's all good stuff and good reason to have HTTPS on your site at all times. In terms of security as a feature, so many times that businesses think about features as something that's going to make them money, whether it be something new on the product detail page in terms of e-commerce, ability to zoom in on a product, or a new way to select a product, or you talk about checkout, maybe some address validation, features that are benefit for making money. Getting a return on investment. So just as if your checkout system was failing to transact money on 1 out of 10 instances, or how would you react to that? You would go ahead and fix that. In a similar context, if your system was leaking data or exposing customers to undue risk, fix that. Treat that as a feature, get that done, get that in the development pipeline and fix it. Some of the things you want to look at in terms of that, you want to measure that time to resolution. So you can bring that to business and help management understand the benefits of that, as well as making sure you're correcting those issues. So another thing to worry about is security as a feature is during testing. People generally, when they're testing an e-commerce site, would step through the happy path, which is pretty much the home page to a product listing page to a product detail page to checkout and on through. Well, when you're thinking about security as a feature, what's it look like for malicious forms of testing as well? Can you inject bad data into the mix and cause your site to do things that it's not supposed to do? We'll get more into that later as we expand on those topics, but something to concern there. And also, coming from a developer's perspective, as you develop software, yes, you're doing it right. You're following patterns and practices. Depending on time and budget, technical debt may be introduced into the mix, and that's processes or features that you implement to get them done, to get them out the door, to meet timing and budget, but can be improved in certain fashion. And so it's important to allocate time to the team to remedy those technical debts. So, one thing to kind of keep in mind during this whole process is that, security is a feature. If you are not testing security, someone else is, and that someone else that's doing it is not who you want doing it for you. So, definitely, keep that in mind.
How about the first baseline passwords, policies? That comes into play too, doesn't it, gentlemen?
Yes, that's the basics of security. Make sure your passwords are rotated in a fashion. They're, I would say, difficult to reproduce, but easier to remember. I know working with several security firms, they've mentioned they have lists of 9 billion passwords out there that they do their penetration testing with, and so that's interesting. If your password is one of those 9 billion, that's going to be pretty easy to hack. And even coming out of the news just about 2 days ago, GE was discovered using default passwords for their radiology products, whether they're CAT scanners and whatnot. And so that would enable those bad actors to get in, view, or modify patient data. Obviously, you'd have to have access to some of that networking, but coming into the mix of default passwords on e-commerce software or plugins or various things, make sure you get those rotated off of those default passwords into something new.
Definitely. And to build off of what Mike was saying there, I mean, it's essential to enforce these policies so that way your employees and your customers are required to create strong passwords. It's nothing new to the industry, so it shouldn't come as a surprise to anybody. Last I saw, I think the National Institute of Standards and Technology, that's a mouthful, isn't it? Which generates a lot of the cybersecurity and industry best practices. They recommend, I believe it's 8 characters. Somebody can correct me if I'm wrong, but I'm sure that's the latest. Now, that's really, in my opinion, still too weak. I think you need a longer password. The longer password, the better, the more complex, as Mike said. I've even noticed some e-commerce sites even requiring like 10 to 12 length and character length and passwords. So, other things like not sharing your password with anybody can be built into those policies. Not using the same password in multiple places. They're all good security hygiene, password hygiene, and building those into your policies, really enforces that. So that way you can always go back and refer to those, internally in your company.
So certainly that policy has to be balanced between customers of your e-commerce site as well as the people who can get in and manage your e-commerce site. So probably 2 different standards there, and depending on what you're selling and what you're storing on your site as well, certainly that has to be balanced with the business requirements.
Definitely.
We've talked a little bit about certificates, the security as a feature, passwords. How about platform updates, installations, thoughts and concepts on that?
Yeah. So some of the folks on the call here are implementing e-commerce systems as platforms, and I imagine some people who'll be watching in the future will be implementing those as well as custom e-commerce platforms here. So in line of platforms, depending on who you're dealing with, you want to make sure those platforms are up to date. The developers in charge of those platforms are constantly developing and iterating over features. They're patching and fixing bugs. You have to make sure those are up to date. Especially even in the context of open source solutions. While it's getting more eyes on it to peer review those solutions, the hackers are out there looking at that source code as well and can find those vulnerabilities and exploit them, quicker and sooner and compromise your site. So definitely make sure those platforms, as well as various forms of things you install on those platforms, are up to date.
And yeah, if you're not doing it yourself, if you're not building that out from scratch and you have a hosting provider, hold them accountable to that. Make sure you ask them, are you patching? How often are you patching? And you can discover some of that later. I think Jared will get into, pen testing and stuff like that.
Great. Mike, what about source code and protections? I know Jared's going to talk a lot about that. What are your thoughts on that?
Well, a source code, for those who are unfamiliar with the term, is the software code, the language, the programming elements that control your website, make it run behind the scenes. And the source code is generally developed by developers who either compile it or work it into a build process that pushes the code up to a website and makes sure your website run. Some of the things with an e-commerce site is you want to make sure that your developers, if you have a team of developers, are doing source code peer reviews. Typically, what we do in our organization, we have a developer write code. Skipping a lot of the steps here, but developer writes the code and another peer looks at that to make sure it's safe, to make sure they're not doing anything they shouldn't be doing, exposing information they shouldn't. Again, that's a human factor in the mix. There are tools that we'll be talking about later that really help bring that out other things that may be hiding in that code. So another thing, keep your credentials out of source control. Credentials to external web services that your website may call to get information from. We're talking about the automated build processes. That's the process where it takes the code, wraps it up, and makes it ready for that production environment. So making sure those processes are streamlined, bulletproof, and can reproducibly deploy code from your developers out to the production environment. And so let's talk about source code access as well. Make sure that source code is of limited access. You typically wouldn't want to put a code repository on an external site and let people review that if it's your own proprietary source code. Certainly there's arguments can be made for open source versus non-open source. I'm not going to get into those here. Talking about making sure the code that goes out to your website, make sure whoever's deploying it, whatever's doing it, has multi-factor authentication. And we'll talk more about that as well. And so that if somebody's password is compromised who has permissions to get to these production environments, they'll need that secondary authentication to make sure you can't just upload code to there. Again, we'll touch on that later as well. So,
thanks, Mike. Hey, Jared, he touched a little bit on the system development lifecycle. Can you expand on that for us?
Yeah, absolutely. So what we're really doing today is kind of bringing together the three different domains of development and all the practices around software security, as well as the operational and network security, and kind of bringing in that, I guess, the security of all those. So that's called DevSecOps, and we'll get into that term here in just a little bit. But before that, if we go back a little ways, so in 2002, I don't know if anybody remembers, but Bill Gates put out a memo called the Trustworthy Computing Memo. And basically the idea was, hey, we're all getting hacked. Everybody's getting hacked left and right. We need to find a way to do better. So I don't know if you've got the slide that you could put up with the secure development lifecycle, but Microsoft came out with a version of processes and touch points around software security. So you can see there on the chart, there's training for developers, and then there's the requirements around what should we, put into the security? What type of encryption has to be used? Does it have to be encrypted in transit, at rest? All of this sort of, kind of what they call bug bars or code quality gates associated with that. And then there should be a design review of that. So the idea is that the more you can push security to the left, the better off you are and the cheaper that security is, which is essentially the basic premise of the business case for security in general, which is you can either pay now or later. And if you pay later, it's going to be more expensive because you're going to be patching fielded products. You're going to be probably going through an incident response and paying an incident response firm to help you deal with the whole mess there. And there's a whole process associated with responding, which is on the very far right, which that's what used to happen in software security, which is we would build all our stuff. And then at the very end, we'd maybe get an expert review or a pen test or something like that, which is great to do. That's still part of the process. But then after bugs were found, it's like, hey, how do we sort of glaze security on to our processes in a sort of reactive way? And so this trustworthy computing, or the STLC as this is called, was really created to push more of that investment to an upfront basis so that you can have more reliable, safer software that will also cost less as well if you're doing that whole portion of it right. So there's threat modeling, the design before. So in a lot of these first three things, they happen before you ever write a line of code. Okay. And then once you get into the implementation phase, it's what tools should we use to write the software, the most up-to-date versions of our IDE, which stands for development environment, like Visual Studio or whatever, and the different types of code scanners and all of those things that can be employed to find bugs as early as possible. That's called static analysis, because we're doing the analysis statically on the source code. And then once the code is sort of 80% ready or so, something like that, there's a verification phase, and we get into the dynamic analysis, and there's other types of testing like fuzz testing, but it's all about basically exercising the software as it's running, so that you send this message or you run this thing, and then, oh, the whole software crashes or whatever. And that's how you can kind of uncover those types of vulnerabilities during the verification phase. And then of course you've got a release phase where we look at, okay, now it's time to publish our website, or it's time to do whatever, ship our software, our car, or whatever it is we're making. And we've got a final security review, pen test of that, often a third-party review. We've got a plan when incidents do happen. Maybe we even have some sort of bug bounty situation and process where if external researchers find vulnerabilities, there's a way for them to report them and maybe even get paid if they find something. And that whole part of the release. And part of that's protecting your intellectual property as well. If you do have, a lot of significant intellectual property, you want to make sure that you obfuscate your compiled binaries in a way that they can't be easily reverse engineered by hackers. And then of course, the worst case scenario is the respond phase, but there's always going to be some type of respond that should be done. So that's kind of the monitoring and kind of watching to see how, maybe if you have a website, you can actually monitor it as it's going. So that's kind of the SDLC. So if you have the second chart on the CICD DevSecOps pipeline, James, there you go. Thank you. So basically, that was kind of the SDLC was, all about getting adoption, getting buy-in from management, shifting security left. All of those principles still apply today. Nothing that's been done previously in security doesn't still apply in any way. Although, of course, your level of investment and how much you do and with what staff do you do it with, and do you have a central security team if you're a bigger company, or really in many cases you want to push security responsibilities at least partially to the development group, so there's an embedded security engineer on each team. You probably want some hybrid of both if you're a big enough company where you still have a central security team and you also have like at least maybe one security engineer on each major project. Again, you kind of have to tailor these. There's a lot of different models out there. There's one called BSIM by Synopsys, and there's another one by OWASP, and there's lots of different standards and things that you can follow as far as what are the exact touch points that make sense based on our software. But a lot of those were kind of more designed for this waterfall method, which was really like we plan, we create, and then we shrink wrap, and then we ship, and then you can go buy the software at Walmart or something like that. But as you know, that's not really how products are made today. In many cases, you may be shipping every day a different updates, minor updates to your mobile app or web app or whatever it is. So that rapid development style is called Agile, or sometimes it's called DevOps, because the operational security people or operational people, if there's no security, hopefully there is, are working directly hand in hand with the development folks, and you're kind of constantly developing and shipping in a constant cyclical feedback manner. That's also called CICD, which stands for continuous integration, continuous delivery. And that pipeline is all about how do we create code, how do we build the code, how do we test the code, and then how do we deploy the code, and then how do we monitor the code? So that's the dev, the sec, and the ops all working together. So I've got some tools here shown, and these are not tools that we're recommending or anything like that. There's plenty of open source tools. Most of these I think are all commercial tools. So just depending on your budget and your size, there's a tool for everyone in here. And you also don't necessarily have to employ every piece of this, right? So for example, if we go left to right real quick, IDE plugins are features that are meant for developers as they're writing code. And same with pre-commit hooks. Those are basically, as you're basically committing code, there's going to be some analysis and scan done on that. As well as, one of the mistakes we see is that sometimes developers accidentally push secrets in their code, maybe to a public code repository, which obviously is a big, oops, I just pushed the Amazon keys to a public repo. Now somebody else could go and find them and log into our AWS account. That would be really bad. So having a secret management scan is really important. And then we get into the SAST, which is all about kind of like a spell checker, if you will. It's checking the code and looking for obvious mistakes in the code. And what's great about SAST, we'll get into this a little bit later as far as, each piece of what's good and bad about SAST and DAST and I guess I'll save that for a future discussion where I jump into those and kind of get into each piece. But I guess I just want to say that, as we look at the commit, the build, and the deploy, it's enough to know that there's touch points and tools, and depending on how mature or maybe small or not mature your organization is, maybe you don't start out with very many of these, you kind of work toward maturity. So there's a continuous maturity assessment that you can do to kind of see, okay, we're at a level 1 now, how do we get to a level 3? Maybe it means adding DAS, we don't do that right now, that type of thing. So I'll save the discussion for talking about each one of those as we get into that. But I guess I first wanted to mention that there is also this notion of as code. So we've got infrastructure as code, we've got security as code, it's a kind of a buzzword that you'll hear a lot, like everything as code. And what that really means when you talk about infrastructure as code, for example, it means that you're dynamically spinning up a cloud environment with maybe certain types of images, like they're called Docker images, or other types that you could use. And so all of that scripting and infrastructure can be spun up and spun down every time there's a check-in, a build, a deployment, that type of stuff. And we can do the same thing with code. That's why it's called security as code. That all of the scans and the things that we want to do throughout this DevSecOps pipeline should be built into the code. So I don't know if that makes perfect sense or not, but I guess I wanted to turn it back over to Mike or Kevin for a little bit. I know they had some things on different types of vulnerabilities that we often see, like SQL injections and XSS that they were going to mention.
Yep. So we're going to talk web risks now. So we've had a chance to talk a little bit about the network, the platform. We've talked about development of the code. So now you're out there, you've got it on the web. What types of risks do they need to be aware of, and how can they manage that?
I'll take a crack at that. Coming from the development perspective, there's a lot of things you can do inside of your source code to create vulnerabilities. And those are some of the things that Jared was talking about, trying to prevent from happening. But kind of more specifically, things on the OWASP top 10, that's your Open Web Application Security Project. And that is generally an industry community-based site that lists vulnerabilities that are common in the web application space. So I'll just cover a handful of those, but you can certainly look that up at OWASP.org. One of the top ones on the list is SQL injection. And that is really, what that is letting untrusted data be sent to your system and being treated as part of a command or query. Kind of for example, if you have an e-commerce site, imagine that you're looking at the product listing page, and you have a list of products. Obviously, it's showing images, it's showing descriptions, it's showing some pricing information. If your site was vulnerable to that, what could happen is that a bad actor could modify something maybe in the query string that is used for a search, or a category ID that is used to display that category of products. What they could do then is inject specially crafted code that would allow them to either delete or modify that data, and or list other forms of data to the screen. Seen that done before. It's fairly interesting attack, and maybe what someone would do to employ that would be the attacker may not be familiar with the database that they're trying to attack. But however, most databases have utilities within them that allow a developer to query the database itself and say, hey, give me a list of tables in your system. Give me a list of columns, database columns in those tables. Potential attack would be, if you had a SQL injection vulnerability, is that, and let's say you were following other bad practices, and you had a table full of users, and the database table full of users had passwords in clear text. Again, all bad practices, don't do that. Someone could essentially say, write a query through that query string and list out the tables
I was just going to jump in real quick and just say that there's obviously tons of different types of attacks, whether it's file uploads or SQL injection or cross-site or spam or malware, different kinds. We do have a chart, Jim, if you want to throw that up on our third slide, just shows some of the attacks that were still pretty common. And some of those attacks are pretty well known too. And the fact that we still see well-known attacks showing up over and over again is something that I thought was interesting to point out. And so as you're talking through these, it's just kind of, this was at least one group's take on what they saw were the most common attacks in Q2 of 2020. So common things like you're talking about SQL injection and cross-site scripting and other types of file uploads and stuff. I just figured I'd throw that in there and let you keep going. Very good.
I did two more that I'm covering on the list here. Sensitive data exposure, through IDOR. That's your insecure direct object reference. That's just a bunch of technical speak for allowing somebody to access a piece of data via some sort of ID that can easily be guessed. And so kind of think about, you've got an e-commerce site, you somebody places an order, you got a thank you page, and in the URL to the thank you page, you might have something like an order ID that would essentially handle the credit card processing and then show that information to say, here's your order, print your receipt kind of things. Well, if that ID is easily guessable and it doesn't have the appropriate protections in place, somebody could imagine it's an integer. Somebody could essentially take that integer and increment it or decrement it and see a prior guess order on your system. And so that's using that ID to expose sensitive data. And I've seen, plenty of that in client systems. We're going into triage things or evaluate systems, other forms of it, and not necessarily e-commerce related, but, other like invoicing systems of where a customer might log into a portal or something and want to see an invoice. Well, again, if somebody puts an invoice ID that's an integer and it doesn't put the right protections around it, they could bring up other invoices. And so what does that matter? Well, if you have a competitor into your system for some reason, could they steal your customer data, steal your customers? Certainly those are very dangerous forms of exploitation. So, and one thing that Jared mentioned was web server uploads as well. Seen a lot of attacks in logging systems where platforms or components that you buy allow people to upload files to your system, whether it be an image for a product type of repair or PDF for resume tracking or some reason. Well, if those file uploads aren't secure, aren't looking for the right files, they could upload a executable code file that would then expose lots of vulnerabilities. So definitely keep an eye on those and make sure you know what you're doing when you're installing those types of tooling to allow customers to upload data to your site.
How about then? I know you've talked about that. What about when we're talking about web app firewalls? Kevin, Mike, what do you think about those? And then Kevin, I know you've got some thoughts in regards to the platforms and the back end and some of the security aspects you should consider as well. How about firewalls?
Yeah, sure. I can start out there, and then I don't know if Mike or Jared has more to add as far as web application firewalls go, but they're basically like your traditional firewall, but they're placed in front of a website or your e-commerce site or a website, either in like a hardware or a software form factor. I think the most common type we see nowadays is like some type of SaaS solution. I won't mention any specific vendors, but you could always Google that or reach out to your hosting provider, to get just the kind of vendors that would have that kind of service for you. But they typically use like signature-based policies or rule sets to look up for these specific types of attacks that Mike and Jared have brought up.
Yeah, Jim, and if we want to bring back up the second slide with the CICD pipeline, it kind of shows where web app firewalls fit into kind of the overall process from build to deploy.
I'm going to interject a question real quick. Based on that chart, we have a question: what AppSec training is best for developers when targeting these sort of problems we see in security?
I'll jump on that one real quick. There are lots of different types of training out there. I've even got courses on Pluralsight and places like that. And so there's different things that you can go and look at. But actually, I think the best type of training that you can get for developers, if you're large enough to build your own training in-house, is to actually go and take examples from your own code, figure out where your developers are actually making mistakes in the products that they're creating, and customize the training around that and allow for developers to contact the security people and say, I want to take that class. I want to learn where we made mistakes and where we can get better and how we can grow and kind of how does this actually work? I want to do hands-on exercises that allows me to actually see what it's like to goof something up and then have to exploit it and fix it. So that's the kind of, sort of hands-on technical training that I would recommend, as opposed to, there are a lot of fluffy trainings out there that are sort of like, they talk about just kind of like, just in general, don't do bad code. And they kind of use a lot of real general terms. And I find that when you speak down to very smart people like developers, it's not as well received, where if you speak up to them and actually really teach them something deeply technical, they enjoy that more, I think.
All right, thank you. So going heading back, firewall. Had you guys finished that? If you have, I know Kevin, you've got some thoughts in addition to taking care of the web and looking at it from that perspective, some internal in-house things that can be done to secure yourselves.
Yeah, as it pertains to threats, to the e-commerce network itself, rather than the web app, there's a lot of threats that are out there. Obviously, we don't have enough time to go over all of them, but some pretty common ones are, one of them I'm going to name is bots. A lot of people are familiar with bots, and bots can be good. They're like the ones that crawl the internet and search engines and bring up relevant results for you when you Google something. However, they can be used maliciously too by attackers. And one specific bot attack is known as a scraper. It will actually scrape your website for inventory information, pricing information. It could even buy up your stock, so that way the attacker can resell items on eBay for a higher price. And we actually see this happening right now. This is happening today with the new PlayStation 5 release. I'm sure a lot of people have heard, you can't buy them, you can't find them anywhere. It's pretty common, it's around the holidays, but still it's happening so often, and people are making money off of it, that they said, well, let's automate this somehow with a malicious tool. And so as soon as the PS5 went up for sale, stores sold out of their inventory within seconds, because these attackers, they had bots and they're out there and they're buying them. And now, the normal price of a PlayStation 5 was $500, and now you're finding them on eBay for $1,500, and people are buying them because they want them right now. So yeah, these automated site visits from the bots can also mess with your website analytic, showing how many visits are coming to your website, and because they're not legitimate people coming to your website anymore, they're bots, and they're messing with your analytics and your marketing and all that.
How about phishing, squatting, other thoughts?
Yep. Yeah. Phishing is another common one. And it's another very common but very effective threat. It's been around for a long time, and it's almost in every cybersecurity webinar that you ever go to. But it works, right? It works for the attackers. And for those who don't know, phishing emails are malicious emails that try to get you to click on some type of fake link or call a fake IT support number. I don't know how many times I've seen, grandma answer or get an email or get a text message and call a phone number, and it's Apple support, and they want to look at their account, or Amazon support, and they want to look at your account, and then they're having you reset your password, and they're assisting you. They're telling you go to a URL, which is downloading legitimate remote support tools like GoToAssist or GoToMyPC, and you're allowing the attacker right into your network by doing that. So and then they can do whatever they want. They can initiate file transfers on the back end and everything. So yeah, these phishing attacks, they try to get information from your company, personal information about your employees. Sometimes they're phishing attacks that look like they're coming from your company to customers. And a common defense that I see is companies making it aware to their customers that they're never going to send them a link. I'm never going to send you a link. Don't click on it. So that way your customers know that. So if an email comes out that's fake to that customer, that's fake from your company, they know that that's malicious, and to go directly to the website or to call the phone number, your 1-800 number directly, and work with your company directly to figure out any issues.
Hey, let's hit typo squatting here real quick, and then I think we can pop over to Jared again and talk a little bit more about the AppSec program and how you can protect against threats. What's typo squatting?
Yep. So typo squatting is when an attacker will buy a domain similar to yours with a mistyped URL that leads them to like a fake or fabricated site that'll steal their information, and it creates a reputational damage for your company, really, and it creates customer trust issues for your company too. For an example of this is, you could do it right now. You open up a browser and you try to type in a variation of Amazon. So if you add 2 A's when you type in Amazon.com, it'll actually redirect you to Amazon.com. And Amazon does this for brand protection. So that way, attackers can't buy up, an Amazon domain with 2 A's or 2 N's and, fabricate a fake Amazon website. Now they're still out there, but, buying up like domains, like misspelled, common misspellings of your brand, of your logo, anything like that is good, best practice.
Okay, so we've talked about the firewalls and the different threats to the websites and doing those things. Jared, this ties back into the AppSec and development. What are your thoughts along that? And can I bring up another slide for you?
Yeah, sure. We just had those 3 slides. So the third slide, you could bring that up real quick, but all I wanted to point out on the third slide was just that we still see too many of the what's called OS top 10 vulnerabilities, the SQL injection, the cross-site scripting. That's what we were talking about earlier. And that really relates to there's not being enough security investment. There's really not people investing early enough in the life cycle to train developers and to work through tools and to show a better path. So some security folks and security pen testers and engineers, they have this habit of sort of, coming in and finding a bunch of vulnerabilities and breaking all this stuff, which is great. You need to do that, but then not really kind of providing a paved road or a roadmap that's, that's more proactive and saying, hey, instead of you doing this and then I find it and say no, or you doing this and I find that and say no again, why don't we just do it this way? And so that's kind of, building a security AppSec program from the ground up if you have to, if nothing exists at your business. Having a Slack channel internally at your company called AppSec even, where people can talk to your security engineer and ask questions about, hey, is this type of crypto appropriate? Or how do I encrypt this type of header? Or what do I do? Is this, code going to lead to, an SSRF or an IDOR vulnerability or some of the different types of vulnerabilities we found? So that's kind of really all I wanted to say about the AppSec program in general. So if you want to go to the second slide with the CICD, I'll just point out a couple more things that I think are worth mentioning is that, all of these different tools and techniques, again, you don't have to employ every one of them, but they should all eventually feed into a vulnerability management program or a monitoring program. So like your web app firewall and different types of monitoring tools, they can be feeding into like what's called a security event monitoring tool or a vulnerability management tool, as well as your SAST, DAST, and other types of, there's RASP, there's IAST, there's SCA, there's all these different types of scanning. And I could go through each one of those in detail, but maybe I'll just say a couple words on some of them. But they should all feed into these other tools so that you can get a sense for, is our security program, are we making progress? Are we training the developers? Are we, or do we see more or less vulnerabilities over time? That type of stuff. So just to pick a few of these, the SCA, this component analysis, basically what that is so much software is built with third-party components. This is in the build area that we want to make sure that the third-party libraries we're leveraging are secure. That's really important. This SAST, again, that's kind of more the spell checker, checking our own code, scanning that. And the DAST is more of the runtime that I talked about. They have different features, like the SAST gives you that broader look of all your code, where the DAST is going to give you more specific actionable results with less false positives. And there's other types of compliance and newer types of scanning like IAS that I probably won't go into this sort of the nuances between them all. There's a lot of overlap between some of them, but I think it's enough to say that as much of a security program as you can build, even if that's just one engineer at a very small company saying, hey, I think we should start by, getting some plugins for our IDEs or some pre-commit hooks or whatever we could do in terms of starting to build out this pipeline. I think that's an admirable goal to work toward.
Okay. All right. So what about like component analysis, dynamic analysis, pen testing? What are your thoughts, panel, on that?
Yeah, so I'll just say one more thing on that. Kind of covered the static, component, dynamic just really quick, but the pen testing, like I said before, is something that we do see a lot of. It started more in the corporate environment, right? So pen testing networks, so external trying to hack into a company, and internal trying to hack within a company, and targeted spear phishing and all the different types of security consulting practices that can be employed. And they're very important. They're very useful, because what happens is a lot of times I think companies, they don't think they have a problem. They're like, oh, I think we're doing pretty good, until they get a pen test and they realize, oh, wow, there was like 20 high, severity findings. I had no idea the kind of shape we were even in. Like, we're lucky we haven't been hacked twice since last month because of the types of holes we're exposing, right? So pen testing is a very important thing, but it is more of a, like I said, it's kind of like it's where you begin. It's not where you end in terms of maturity. So you can start with that, and then you can raise some awareness internally and let management and other people realize the type of situation that we have. And then from there, that's when you can begin the real work of actually building an AppSec and a security program. Because if you're really building a good security program and a good AppSec program, you really shouldn't be finding as many bugs during those pen tests, whether it's on the code or the network side, because you will have more proactively addressed and invested up front on a lot of that. So that's kind of the main thing I think about when I think about how does pen testing fit into any sort of the DevSecOps.
Okay, thanks, Jared. A lot of people talk about MFA, when you talk about protections and all those different things. You want to explore MFA a little bit and share your thoughts on that?
Yeah.
Sure,
Yeah,
sure. I'll take a crack at it first here. Yeah, multi-factor authentication, or 2FA, two-factor authentication. You've seen that all over the internet now. At this point, it's your password plus something, a device you own. So something you know and something you have. So that's definitely becoming more and more imperative to have, especially when it comes to e-commerce sites. If one of your users had, like administrative users, had their password hacked or tacked or cracked or whatever, a malicious actor could get into the website and go into your administration tools and change the site ever so slightly and begin stealing credit cards. So to combat against that, having that second degree of authentication, that multi-factor device, whether it be an app on your phone or some other certificate or something like that, definitely must have for the site admins who manage the content on your site. Kind of digging in a little more there, seeing recent industry trends, even content editors who put JavaScript into the pages, mandating that they authenticate into your CMS systems with that two-factor authentication to remove that attack vector of putting, a content editor putting JavaScript on the page that steals information from users. So that's definitely imperative. So get that two-factor authentication enabled on your sites, whether it be your tag managers, meaning Google Tag Manager or Telium or type things like that, whether it be your CMS tools, your e-commerce systems, your order management systems. Get those two-factor authentications in place, and that's some easy, typically easy things to do there.
Yeah, I'll jump in real quick on that too and just say that even for just everyday accounts like my Gmail and whatever else, I really think most users, there's free password managers tools out there. There's one called LastPass, for example. I use it for all my accounts. So, I mean, we mentioned a certain length of password, but the longer the better. And of course, you can't remember a completely random 20-character password, but LastPass can. So you have one password that's your last password that you need to remember, right? And then you unlock your password vault, and then it basically inputs these 20-character totally randomized passwords into whatever site you want to log into automatically for you. So I don't know any of my passwords really hardly, because the password manager does that for you. And then enabling MFA on top of that for all your accounts it's a little bit trickier. You can get goofed, at times if you lose your phone or something, you need a PIN to get into accounts. But I find that to be pretty helpful too, because sometimes you'll lose those passwords, no fault of your own, right? If LinkedIn gets hacked or Yahoo gets hacked or whatever, all of a sudden your password to that site's gone. You didn't necessarily do anything wrong, but people still can't log in because you've got, I use Authy, there's other ones, Google Authenticator, there's lots of free options out there. You can just go in, put in your user and pass, throw in a PIN too, and that makes the site pretty secure. It's a lot harder to get into people's account takeover is a huge way that companies and people are being breached on an everyday basis.
Yeah, and to add to that too, if you do lose your phone or something like that, it's a minor inconvenience, but think about what the inconvenience would be if somebody got into your account and accessed all your passwords or accessed your email or anything like that. I do like to put a disclaimer out there when it comes to MFA. Sometimes they can provide a false sense of security just because you think you have this second factor and nobody can log into your account because they have your password, but they don't have your MFA piece. So what I like to say is that's great to have. I think you should have it. You need to have it. But you need to watch your logins too. What a lot of softwares are doing now when you log into them, they're telling you your last login time and if it was successful. And some of them even tell you where those logins are coming from. You need to pay attention to that because if an attacker did, say, phish you with a phishing email and you gave away your password, and not necessarily can't log in, but they're going to try to find a way or a place that you don't have MFA enabled to then try to get in.
Okay, with that as a backdrop, we've had a great conversation here. One final question for each of you folks is, if I'm a business person, where do I get started? You've talked a lot about all these different aspects today. Final thoughts on how do I bring this to life? What are your thoughts? Let's start with you, Mike.
I think my number one thing would be education and training, understanding, the vulnerabilities as a, software architect and a developer who is actually writing code, understanding what those are. So then as I'm writing code, I can then mitigate against those or not make the mistakes that are subject to the problems.
Kevin.
I think we're doing the right thing by being in this webinar right now and getting educated, spreading the awareness, as Mike said, getting educated, spreading that awareness. And when you think about it, really, when you focus on something, say you focus on your budget at home, or, you focus on education, or when you focus on something, you're going to have a better outcome for it rather than just letting it sit in the background. So just putting your sights on it and chasing it down is going to be the best way to get started.
For me, I would start with the business case, actually. So I think, security is like, a form of risk management in a way, right? So basically, what's the worst case scenario? If our company were to get completely breached and we lost all of our customer source code and all of our customer data and credit card, whatever your company does, what would that cost your company? And then kind of work backwards from there and basically figure out, okay, what's appropriate? Like if you have nothing to protect, then don't spend anything on it. But if your company is worth $1 trillion and you could lose all that trillion, maybe it makes sense to spend $1 billion on security or whatever. So you really need to kind of look at your business case and figure out, what do we really need? What's appropriate for us based on our particular, every place is different. There's really no one size fits all. So that's kind of how I would begin if you're sort of starting from completely scratch.
Okay, well, panel, it's been very informative. Jolene, do we have any additional questions coming from the audience?
I do not, but I encourage everyone to send in questions. If not, I'll be sure to follow up with an email for those who attended with contact information or email so that they can get with us directly and if they have any after this.
All right. Well, today it's been very informative, guys. It's real important. Obviously, if for many organizations, this is the opportunity for the future, at least in the current environment that we've got next 12 to 18 months. This is a different channel that you can get product out the door. And you've given us a great framework to get started. So Jared, thank you. Kevin as well, and Mike, and then Jolene and Eric, you guys put a lot of time and energy into getting this up and running. I'd like to thank the audience for attending as well, and wish everybody a happy holiday. With that, we'll wrap this down. Thanks all.
Take care. Thank you.
Take care.
Bye.